9 questions have been given from the section circles in the JEE Main January 2024 session. The first 6 questions we have already discussed in 2 different videos, each consisting of 3 questions. In this video, we discuss the last 3 questions from the section circles. This question has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is, let a variable line passing through the center of the circle x square plus y square minus 16x minus 4y is equal to 0 meet the positive coordinate axis at the points A and B. We are given the circle, this is the circle, and we are given a variable line is passing through the center of the circle, and that variable line meets the positive coordinate axis at A and B. Then the minimum value of OA plus OB, where O is the origin, is equal to, we are given 4 options. Required to find the minimum value of OA and OB, where O is the origin. Let's now discuss the solution of the problem in detail. We have the given circle, yes, given by x square plus y square minus 16x minus 4y is equal to 0. Let's write down this as x minus alpha whole square plus y minus beta whole square is equal to r square. We get alpha is 8, beta is 2, r square is 68. Therefore, the center of the circle denoted by C, whose coordinates will be 8, 2, and the radius r is under the square root of 68. Right. That's our x-axis, y-axis, and the origin, and that's our circle S, whose center is C with coordinates 8, 2. Right. What is given to us? Given a variable line L is passing through the center of the circle S. We have a line L, but it is a variable line. It goes on varying, and this line L, variable line, is passing through the center of the circle C 8, 2 and meet the coordinate axis at A and B. So given L meets the positive coordinate axis at the points A and B, A here, B here. And mind you, this line is a variable line, and thereby, as this line is a variable line, the A and B's will also vary. Agreed. Now, the slope of this line L must be negative. Why? Because it is like this, and always it will be like this only. And the angle that this line is making with the positive direction of the x-axis will be obtuse, and thereby tan of that will be negative. Therefore, we take minus m as the slope of this line, where m is positive. The equation of the line L will be it's a line passing through 8, 2, whose slope is minus m, where m is greater than 0. Then equation is y minus 2 is equal to minus m times x minus 8, where m greater than 0, where m is a variable, because the line is variable. Right. Now OA, what is OA? OA is the y-intercept. To get the y-intercept, put x is equal to 0. Then you will get OA will be 8m plus 2. The OB, the x-intercept, put y is equal to 0 in this and solve for x. Then you will get 2 by m plus 8. Right. Now OA plus OB will be 8m plus 2 plus 2 by m plus 8. OB is 2 by m plus 8, where m is a variable. This will be 8m plus 2 by m plus 10. That is equal to f of m, where m is a variable. And we have to find out OA plus OB when it is the least, and find out the least value of that. So to find, that means we have to talk about the minima, maxima, minima of this one. So for that, first derivative f prime m is equal to 8m, derivative is 8 minus 2 by m square. 2 by m square is equal to 0. Equate it, then you will get the stationary points. M square is equal to 1 by 4. M will be plus or minus 1 by 2. We take m is equal to 1 by 2 and reject m is equal to minus 1 by 2 because m is positive. Right. Then f double prime m, that means the second derivative will be the derivative of minus 2 by m square with respect to m is 4 by m cube. For m is equal to 1 by 2, it is positive. That means f of m attains minimum when m is equal to 1 by 2. So what will be the minimum value? F min is f of 1 by 2. F of 1 by 2 is in f of m is equal to 1 by 2 is substitute 8 into 1 by 2 plus 2 by m, 2 into 2 plus 10, that is 18. The minimum value of OA plus OB is 18. Let's look at our options. Our answer, the minimum value of OA plus OB is 18, appears against option 3. Therefore, the answer to this question is option 3. And that is the detailed discussion of the solution of this problem. It is definitely easy problem, but not very easy problem. Agreed. I am sure that you have understood the solution of this problem. Let's now move to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the first shift. The given question is, let C given by x square plus y square is equal to 4. C is a circle. And C prime given by x square plus y square minus 4 lambda x plus 9 is equal to 0. This is also a circle. So there are two circles. If the set of all values of lambda so that the circles C and C prime intersect at two distinct points is R minus the closed interval a comma b, then the point, the ordered pair 8a plus 12 comma 16b minus 20 lies on the curve, and we are given four options. So we are given two circles. In one of the circles there is a lambda, and we have to find the set of all the values of lambda such that the circle C and C prime intersect at two distinct points, and that set is given to be R minus a by a comma b, the closed interval a comma b. Then required to find the point a, the ordered pair 8a plus 12 comma 16b minus 20. This point lies on which of the following four curves? Agreed. Let's now discuss the solution of the problem in detail. Right. We have two circles. The first circle is C, x square plus y square equal to 2 square. Its center is C1 at the origin 0, 0, and its radius R1 is 2. And it says the second circle C prime, it's given to be x square plus y square minus 4 lambda x plus 9 is equal to 0. Let's now write down as x minus alpha whole square plus y minus beta whole square is equal to r square. Alpha is 2 lambda, beta is 0. and the center of the circle is C2, which is given by 2 lambda minus comma 0, and its radius is under the square root of 4 lambda square minus 9. Agreed. Now, let S be the set of all those real numbers lambda such that C and C prime intersect at two distinct points. Two circles intersect at two distinct points, and we have a condition. That condition is the set of all those lambda belongs to R, the set of real numbers, such that modulus of R1 minus R2 is less than the distance between C1 and C2 is less than R1 plus R2. This is the condition. Yeah, we have studied this. This is the condition. So that will be the set of all those lambda belongs to R, the set of real numbers, such that mod of R1 minus R2, R1 is 2, R2 is under the square root of 4 lambda square minus 9. C1, C2, the distance between C1 and C2, C1 is 0, 0, C2 is 2 lambda, 0, and the distance between C1 and C2 is mod 2 lambda, and it is less than R1 plus R2. Right, we have written that one. And this is the set of all those lambda belongs to R, and to make sense for this under the square root of 4 lambda square minus 9, 4 lambda square minus 9 must be non-negative, that is greater than or equal to 0. Then it will be a real number. Right. And this condition is anyway there. So that will be equal to the set of all those lambda belongs to R. 4 lambda square minus 9 greater than or equal to 0 implies 4 lambda square greater than or equal to 9. Lambda square is greater than or equal to 9 by 4, and the second condition. And lambda belongs to R. Lambda square greater than or equal to 9 by 4 will be all those real numbers that lie in the minus infinity to minus 3 by 2 union 3 by 2 to infinity is a semi-closed interval, is closed at 3 by 2 end. Intersection, end means intersection. Set of all those lambda belongs to R, and this condition is there. That is mod of 2 minus under the square root of 4 lambda square minus 9 is less than mod 2 lambda less than 2 plus under the square root of 4 lambda square minus 9. Agreed. So we will attack this one and find out the values of lambda, then take the intersection, then you will get your S. Right. Our concern is to find S now. So S is this. So we take this second condition. So mod of 2 minus under the square root of 4 lambda square minus 9 is less than mod 2 lambda is less than 2 plus under the square root of 4 lambda square minus 9. Right, we will square on both sides. So square it. So this is the square of it. And mod 2 lambda square is 4 lambda square. And this is the square of this one. Right. So you will get 4. So in this 4 lambda square cancels throughout. 4 lambda square cancels throughout. Then you will get, if you get 4 lambda square cancels throughout, 4 minus 9, that is minus 5, minus 4 under the square of 4 lambda square minus 9. 4 lambda square is cancelled throughout, therefore 0 is less than minus 5 plus 4 times under the square root of 4 lambda square minus 9. And we write this as two inequalities separately. The first one and the second one, 0 with 0. And this is equal to, this will imply minus 5 less than 4 times under the square root of 4 lambda square minus 9 and 5 less than under the square root of 4 times under the square root of 4 times under the square root of 4 lambda square minus 9. We will go back here, and that will be 4 times under the square root of 4 lambda square minus 9 is greater than plus or minus 5. Squaring on both sides, we will get 4 lambda square minus 9 is 5 by 4 whole square, that is 25 by 16. Solving for lambda square, you will get 13 by 8 whole square. The computation is shown here. Lambda square is greater than 13 by 8 whole square. And this is lambda plus 13 by 8 multiplied by lambda minus 13 by 8 greater than 0. If this is the case, then what are the values of lambda? Lambda belongs to minus infinity to minus 13 by 8 open interval union open interval 13 by 8 union comma infinity. So this is for the second inequality, this is the lambda value. For the first inequality, this is that. So let's go back to S. Go back to S. S is equal to this, the union of these two intervals, intersection, the union of these two open intervals. These two open intervals. Right? So this is already there. And for this is the one what we have written here. And take the intersection. Intersection is the smaller of these two. This will be minus infinity to minus 13 by 8 open interval union 13 by 8 to infinity open interval union. So let's look at, and this is this union is R minus, remove minus 13 by 8 and plus 13 by 8. Remove that portion in between minus 13 by 8 to 13 by 8 closed interval. Why? It is open here, so closed interval. This in between part you have to remove, then you will get this union. And this is given to be R minus the closed interval A comma B. Therefore, A will be minus 13 by 8 and B will be 13 by 8. So this will be the case. And 8A plus 12, the ordered pair, comma 16B minus 20 is a point, and that is for A minus 13 by 8, for B 13 by 8 you substitute, then you will get minus 1 comma 6. This point lies on which of the following four curves? The four curves are here. These are the options. These are the options. You take this minus 1 comma 6 and go on verifying these conditions, these equations, one after the other. The very first equation we have verified. So you see, for x is equal to minus 1 and y is equal to 6, you substitute. 60 into minus 1 square is 6 plus 6 square, that is 36. 36 plus 6 is 42. And if you see, you will see that minus 1 comma 6 does not satisfy any of the remaining four equations. Therefore, on checking we find this point satisfies the very first equation. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem. And it is definitely not an easy problem, but it is not difficult question. It is relatively, it takes time. That's all. Let's move to the next question. And that is the last question in this discussion. This question has appeared in the JEE Main exam held on 1st February 2024 in the second shift. The given question is, let the locus of the midpoints of the chords of the circle x square plus y minus 1 whole square is equal to 1 drawn from the origin intersect the line x plus y is equal to 1 at P and Q, then the length of PQ is, we are given four options. Right? We are given a circle, x square plus y minus 1 whole square is equal to 1. It's a circle with center at 0, comma 1 and radius 1. And the locus of the midpoints of the chords of the circle drawn from the origin. From the origin, the chords are drawn, and the locus of the midpoints of those chords, the chords are drawn from the origin, intersect this line. So first of all, you have to find out the locus of the midpoints of the chords drawn from the origin to this circle, and take that locus and let it intersect with this line at 2 points P and Q. Then find the length of PQ. It's very easy. Agreed. That's the question. Now we have the circle x square plus y minus 1 whole square is equal to 1. That is the circle's equation S given by x square plus y square minus 2y is equal to 0. You simplify this, you will get this one. Now the equation of the chord of the circle whose midpoint is h comma k is given by t is equal to s1. What is t? The tangent equation. That is xx1 plus yy1 minus 2 in brackets y plus y1 and that will be x1 y1 is h comma k. S1 is x1 square plus y1 square minus 2y1 square. H comma k is to be substituted for x1 y1. So that will be equal to xh plus yk minus y plus k, not 2 into, minus y plus y1, because 2y is to be split as y plus y1, that is y plus k, is equal to S1 is h square plus k square minus 2k. Simplify, you will get xh plus yk minus y is equal to h square plus y square minus 2k plus k is minus k. Right. But this is the equation of the chord of the circle whose midpoint is h comma k, and it is passing through the origin. So since the chord is drawn from the origin, it passes through 0 comma 0. So substitute for h comma k, substitute for xy, for xy 0 comma 0. So you will get for x and y, so x is equal to 0, y is equal to 0 is substitute, you will get 0 is equal to h square plus k square minus k. So that is the equation. The locus is now obtained by replacing h comma k by x comma y. So therefore the required locus is x square plus y square minus y is equal to 0. Thus we got the locus. Now this locus, it is given to be, is intersecting the line x plus y is equal to 1 at p and q. So now take y is equal to, x is equal to 1 minus y, and substitute in the locus and solve for y and obtain the points of intersection of the locus and this straight line. So substitute in the locus, in the equation of the locus, 1 minus y whole square plus y square minus y is equal to 0. Simplifying, we'll get this, and factorization will give you 2y minus 1 multiplied by y minus 1 is equal to 0, y is equal to 1 and y is equal to half. When y is 1, x is 0. When y is 1, x is 1 minus 1, 0. When y is half, x is 1 minus half, that is x is equal to half. So therefore the points of intersection are P at 0 comma 1, x is 0, y is 1, and Q, x is half, y is half, Q half half. We want the length PQ. So the PQ, length of PQ is equal to, use the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. Then you will get under the square root of half minus 0 whole square plus half minus 1 whole square. And that will be equal to under the square root of 1 by 4 plus 1 by 4, that's equal to 1 by root 2. Let's look at our options. Our answer 1 by root 2 appears against option 2, and that is the detailed discussion of the solution of this problem. And in this video we have discussed the 3 questions, question number 7, 8, 9 from the section circles which have appeared in the JEE Main January 2024 session. And I am sure that you have understood the solutions of these 3 questions, and I wish you all the best. Thank you.